Reduction of emissions in power production. My name is Merja Mäkelä and I come from Southeastern Finland University of Applied Sciences. You are very welcome to participate in this learning session. In my presentation, I have three parts. Firstly, I have a small introduction. Secondly, I come to the main topic, combustion technology and emissions, and finally, I have my conclusions. Firstly, this introduction. The Directive 2010/75 of the European Union for industrial emissions makes the general framework for industrial emissions. This directive is applied to energy production, metal production and processing industries, minerals processing, chemicals industries, waste management, pulp and paper production, slaughterhouses, the intensive rearing of poultry and pigs. There is a second important document, and this is called Best Available Techniques Reference Document for Large Combustion Plants. This has been updated in 2017, and this document gives the general techniques to prevent and reduce emissions and their consumption. We get toxic and harmful emissions from combusting power plants. We always get carbon dioxide from combustion. In addition, we may get more or less nitrogen oxides, sulfur dioxide, particulate matter, persistent organic pollutants, and heavy metals. There are many challenges in power supply. There are tendencies to reduce fossil fuels due to the limited natural resources in our world. There are trials to reduce carbon dioxide emissions because of the global warming. The availability of feasible fuels varies from country to country. This figure on the left side presents the total energy consumption in Finland in 2019 to 2015. With the blue color, you see the part of fossil fuels used in power supply. With the magenta color, you see the renewable sources used for the power supply. With the turquoise color, you see the nuclear power part in the total consumption of Finland. This renewable part makes about 40% now, and 30% comes, that part of 30% comes from wood-based fuels, and 10% from hydropower, wind power, and solar power. In this figure, also given in petajoules, you see the renewable energy sources of Finland from 1970 to 2015 in some more details. When we start here on the bottom, using the blue color, it's presented the part of hydropower it makes about 15% or a little bit less. Then another 15% comes from small-scale wood combustion. Then this magenta color gives the part of black liquor. Black liquor comes from pulp mills. Black liquor contains compounds from wood, and it contains a lot of energy, and black liquor is combusted in recovery boilers in order to recover chemicals for further usage. And in that combustion, a lot of energy will be produced. This turquoise color, also about 30%, it comes from wood-based combustion in industries. It means this large-scale production. Then a little bit more than 10% comes from the energy of heat pumps, some recovered fuels and other biofuels. These sources have been increasing during the last 10 years. In this figure, you see the progress of carbon dioxide emissions from 1990 to 2016. The emissions are given in million annual tons carbon dioxide. The emissions in Europe, given using this yellow color, and in the USA, given with a blue color, they have been gradually decreasing after 2000, but not that much. The situation in China looks different. After 2000, the emissions have been increasing because of more industrial activities and also more vehicles in the transport. During the last years, there is a slight change, so in that direction of decrease. In the lower part of the figure, you see the situation in Finland. The annual emissions, carbon dioxide emissions, they are between 60 and 70 million annual tons. After 2010, they have been decreasing, but after 2015, there is a slight increase due to increasing industrial activities. Next, I come to the combustion technology and emissions. This is the main topic here. In this figure, you see a simplified scheme of power production using combustion. On the left side, the fuel is coming in. In this case, coal is coming in to the furnace where it's combusted. This combustion makes heat, and this heat boils water in the water circulation and makes high pressure steam. This high pressure steam comes to the turbine where it releases heat and condenses and makes the generator to rotate, and we get electricity. This condensed water comes back to the water circulation. From the combustion, we get flue gases, and in flue gases we have harmful and toxic emissions, and we have to be able to reduce them. There are three basic principles how to reduce emissions in combustion. We should use cleaner fuels and combustion processes. That makes the basis. Secondly, we should utilize improved combustion technology, and these methods are called primary methods to reduce emissions. Thirdly, we are able to treat flue gases, and these methods, they are called secondary methods in order to reduce emissions. When we use cleaner fuels in combustion processes, it looks like this with some fuels. We get less emissions from biogas and from natural gas. On the other hand, we get significant emissions from some fossil fuels such as oil, coal and peat. We also get significant emissions from some renewable sources such as biomass and black liquor. We get harmful emissions from waste, but on the other hand, we like to get rid of waste. We don't get any emissions from some non-combusting sources. We don't get emissions from solar power, wind power, or hydropower. We don't get emissions from nuclear power, but there are problems with that radioactive waste. We don't get any emissions from that geothermal heat. We are able to utilize improved combustion technology. In this case, there are two basic mechanisms to improve combustion. Firstly, we may regulate the feed of air. This means the feed of combustion air. We may also regulate the fuel feed. Secondly, we may use lower combustion temperatures, and this can be realized, for example, by circulating flue gases. And this method is especially used in circulation fluidized bed combustion. This third method covers different ways to reduce emissions. We may get less nitrogen oxides when we inject ammonia to the combustion, to the furnace. We get less sulfur dioxide when we add calcium carbonate. We get less particulate matter when we use electrostatic precipitators. We get less particulate matter when we use fabric filters. We are able to get less sulfur dioxide, sulfur trioxide, hydrogen fluoride, hydrogen chloride when we dose activated carbon and slaked lime, this calcium hydroxide. We get harmful nitrogen oxides from combustion. Flue gases contain about 95% nitrogen monoxide and about 5% nitrogen dioxide. These nitrogen oxides, they come from fuel's nitrogen and from the nitrogen of the combustion air. The produced amount of nitrogen oxides depends on the reaction mechanisms of fuels and oxygen, and also the availability of oxygen in different combustion zones. The mechanisms are rather complicated, but they are well known. Next, I come to the main combustion methods. Burner combustion is widely used. We use dust with air, we may use fluids, we may use gases, especially fuels with high heating values and uniform quality, such as oil, natural gas, and coal. We may use crate combustion. Today, this method is mostly used in waste burning incinerators. Then those combusting power plants, they burn municipal waste. The third method utilizes fluidized bed combustion. This is widely used when we have multiple fuels with low and varying heating values, and the combustion takes place in fluidized sand beds. This figure presents a biomass combusting power plant. We have a storage for biomass here on the left side, and we feed the fuel into the furnace. This power plant uses this fluidized bed combustion. The combustion makes heat and boils the water in the water circulation, and from that steam we get electricity in the generator. This condensing steam, it becomes water again, and it releases heat, and we are able to use this heat for district heating network. We feed some additional water there. Ashes can be utilized if possible. That combustion makes emissions, and we have to be able to clean them. We like to reduce harmful and toxic emissions. Finally, I come to my conclusions. Harmful and toxic emissions coming from the combustion can be reduced using clean fuels, advanced combustion methods, and cleaning methods. Thank you for your attention and have a nice day.